Section 4.5 is on solving equations that involve radicals. And a radical equation is just basically an equation that contains a radical. A value of the variable in the equation which satisfies the equation is known as a solution or root of the equation. So basically, it's a value that you can plug into the equation and makes the equation true. To solve equations that involve radicals, you basically use inverse operations. So squaring would be the inverse of taking the square root, and cubing would be the inverse operation of taking the cube root. So these are the basic steps we're going to use for solving equations that involve radicals. The first step is to isolate the radical expression on one side. So isolate on one side of the equation, and then you would either square both sides if it's a radical that's a square root, or you would cube both sides if it's a cube root. So isolate, then square or cube, and then you would solve the resulting equation for x. And you should always go back and check your solution back into the original equation. And reject what we call extraneous roots. So extraneous roots are basically solutions that you pick up after you square both sides that will make the squared equation true, and sometimes also make the original equation true, but sometimes they might make the squared equation true, but they don't make the original equation true. And just to kind of give you like a kind of simple explanation as how that would happen, if you consider these two values, for example, 2 squared and negative 2 squared, that produces a true equation because 4 is equal to 4. But if you go back and square root both, go back to before you squared both sides of the equation, if you have 2 and negative 2 and you put an equal sign between them, that's not actually true. So when you square both sides, 2 squared equals negative 2 squared. But if you square root them, 2 does not equal negative 2. So sometimes the one with the square root in it isn't true when you plug that value back in if it gives you something like this statement right here. But it does make the squared equation true. So if you pick up an answer that makes the squared equation true but doesn't make the original true, you have to reject it because it's an extraneous root. Alright, so let's try a few examples. So the first step in A is to isolate the square root. So we want to get square root of x by itself. We want to get rid of that 5. So that's multiplied by this side of the equation. So we are going to get rid of it by dividing both sides by 5. And we'd be left with root x equals 7. And then we want to square both sides. So when we square a square root, we will get what's underneath the square root sign. Square root of x times the square root of x is the square root of x squared, which is just simply x. And basically that'll happen all the time. If you square a square root, you'll get what's underneath the square root sign. So the next example is already isolated. The square root is already isolated, so we're going to go ahead and just square root both sides. Square both sides, I'm sorry. And when you square the square root, you get what's underneath the square root sign. And then you just go ahead and solve that equation. So 3x, you want to get rid of that negative 1, bring it over to the other side, or add 1 to both sides, so that'd be 9 plus 1. So 3x equals 10. And then you want to get x by itself, so you're going to divide both sides by 3. So x would be 10 over 3. And I forgot to go check for extraneous roots back in A. So you should always check your solution back in the original. And you can show it, or you can just do it in your head. We'll just show it for now. So you take the left side of the equation, and you plug it in, and you get 5 times the square root of 49, which is 7, which equals 35. And the right side of the equation is 35, so therefore 35 equals 35, and it is a solution that works. You could also be asked to state the restrictions for this equation, and the restrictions would basically be looking at, you just got an x under the root sign, so the restrictions would be x greater than or equal to 0. Question B, if you want to check your solution to make sure you didn't pick up a root, an extraneous root, the left side of the equation would be the square root of 3 times 10 over 3 minus 1, which would be the square root of, that would be understood to be 30 over 3 or 30 over 3 or 10. So the square root of 10 minus 1, because that square root goes over the whole thing, and that would be the square root of 9, which is 3. And the right side of the original equation is 3, so therefore 3 equals 3, and it's not an extraneous root, it is a solution. So x equals 10 over 3 would be the solution. Okay, so the last one here on the page now, again the square root is already isolated for you, so now the next step is to square both sides. So then you've got x plus 2 equals 9. So x would equal 9, take away 2. If you want to isolate the x, you got to subtract 2 from both sides. So x would be 7. So then if you check and plug it back into the original, the left side of the equation would equal 7 plus 2, square root of 7 plus 2, which is the square root of 9, which is 3. But the right side of the equation is negative 3. So therefore we've got 3 equal to negative 3, which doesn't make sense. So that means that this is an extraneous root. And has to be rejected. So therefore there's no solution. If you look back at the equation to see what was different about this one, look at the original statement, the original equation, and it had the square root of an expression equal to a negative. And we know that when we use that radical symbol, the square root symbol, that we're supposed to get a positive answer. So this one here, even if we had recognized that from the very beginning, the square root equal to a negative, we would have known there should be no solution to that anyway. But when we squared both sides, we did get a solution, because if you plug 7 back into the squared equation right here, 7 plus 2, the square root of that would be the square root of 9, and which is 3, and 3 squared is equal to negative 3 squared. 9 equals 9. So that's why it worked in the squared equation, but it didn't work in the square root equation. So we have to eliminate that as a solution, because it needs to work in the original equation. Okay, and I also forgot to do the, well, it didn't ask us, but you could be asked to state the restrictions. So if we just go back and do that for B and C, if you're asked to do the restrictions for B, you would need 3x plus 1 would have to be greater than or equal to 0, which means 3x would have to be greater than or equal to negative 1, which means x would have to be greater than or equal to negative a third. And that your solution should be within that restricted range of values, which it is. This one here, restrictions for C, don't really have a whole lot of space there, but if we did the restrictions for C, it would be you need what's under the root sign to be positive. So x plus 2 would have to be greater than or equal to 0. X would have to be greater than or equal to negative 2. Okay, so the next one is now cube root, but it has the minus 7 with it, so we want to isolate the cube root on this side of the equation by itself, so we need to add 7 to both sides of the equation, which will give you 4 plus 7 on the right side, and then you've got the cube root of 2x plus 5 on the left and 11 on the right, and then we want to cube both sides of the equation, which will give us, basically if you cube a cube root, you'll get what's under the cube root sign, and then 11 cubed, I'm not sure what that is off the top of my head, so that's 1,331. So then you just go ahead and solve for x, so you want to subtract 5 from both sides, so that's going to be equal to 1,331 subtract 5, which is going to be 2x equals 1,326, and then you want to divide both sides by 2 to get x. So x is equal to 663. And if you want to check, let's just check that one to make sure we did it right. So the cube root of 2 times 663 plus 5 and then minus 7 is going to be 663 times 2 plus 5 is 1331, and then you want the cube root of that. Which is 11. Oh yeah, I should have known that from over there. Anyway, so this would be the cube root of 1331 minus 7, which is going to be 11 minus 7, which is equal to 4. So that is what we wanted. And the next one, next view there, you got to isolate the square root, so you want to bring the 3 over to the other side by subtracting 3 from both sides, and you get the square root of x minus 1 equals 1, and then you want to square both sides, and squaring a square root leaves you with what's under the root sign, and then you end up with x equals 2. And we're back to a square root again now, so we should check to make sure we haven't picked up an extraneous root, and if we check 2 minus 1 would be under the square root sign, check the left side of the equation, and add 3 to that, and we get the square root of 1 plus 3, which is 4, and that equals the right side of the equation, 4. So it's not an extraneous root, it is a solution. And I didn't do it, but if you were asked the restrictions, it would be x minus 1 is greater than or equal to 0, which means x would have to be greater than or equal to 1 for the square root part to be defined. Alright, the next one, very similar to f, you just have to isolate the square root by bringing the negative 1 over to the other side by adding 1 to both sides. So this would be the square root of 2x plus 5 equals 5, and then you square both sides. And that's going to give you 2x plus 5 equals 25, 2x equals 25 minus 5, 2x equals 20, and then you divide both sides by 2, and you get x is 10. And again, you can check to make sure it isn't an extraneous root by plugging it in. And you don't always have to show the check, just so long as if it is an extraneous root, you reject it. But a lot of times I'll just plug it in my head there and do it in my head rather than writing all this out. But if it helps you, write it out. So this is 2 times 10 plus 5, subtract 1. And that's going to give you the square root. 2 times 10 is 20, plus 5 is 25, and that's going to give you the square root of 5, square root of 25, which is 5. Take away 1, which is 4, which is what the right side of the equation equals, so we're done. And that is a solution. If you were asked to state the restrictions, you would need 2x plus 5 to be greater than or equal to 0. So 2x would be greater than or equal to negative 5, and divide both sides by 2. X would be greater than or equal to negative 5 over 2. Alright, the last one there on the page is a cube root again. So again, we don't have to worry about restrictions with cube roots, but we will solve the equation by getting the cube root by itself by subtracting 1 from both sides. And then we've got the cube root of 6 minus 2x equals negative 2, and then we want to cube both sides. And that's going to give us 6 minus 2x equals negative 8. And then we want to isolate the x by subtracting 6 from both sides of the equation. And then that's going to give us negative 2x equals negative 14. And then we want to divide both sides by negative 2. So x is 7. And if you want to go back and check that solution, don't have a whole lot of room here, but so let's just do it in our heads. 6 take away 2 times 7. 2 times 7 is going to be 14. So 6 take away 14 is going to be negative 8. And the cube root of negative 8 is going to be negative 2. And negative 2 plus 1 is going to be negative 1, which works. Alright, so if we just look back to example 1c earlier, if you remember, we got a solution of 7 that seemed like it was a solution, but when we went back to the original equation, it gave us, I can't remember the exact number now, exact numbers now, but it was something like 3 equals negative 3, I believe, or something like that. So it didn't work in the original, so that was an extraneous root. And we already talked about this, about look back at the equation first to see that there's no solution. You can almost tell at the beginning because the square root was equal to a negative, so you know that when you see the square root, you're not going to, you're expecting a positive answer because the square root symbol, this symbol denotes the principal square roots, which should not be a negative. So now we're going to look at a few word problems. And basically the word problems will have an equation that has a radical in it, and you will have to substitute in for the different variables in the equation to get the answer. So the first one says collision investigators can approximate the initial velocity v in kilometers per hour of a car based on the length L in meters of the skid mark. The formula v equals 12.6 the square root of L plus 8, where L is greater than or equal to 0, models the relationship. What length of skid is expected if a car is traveling 50 kilometers per hour when the brakes are applied? So you basically have to use this formula, and they have given you a velocity. So if I just write the formula down again here, you got 12.6 L plus 8. So they have given you the velocity of 50, and you have to find the length of the skid mark, L. So you have a radical equation. So we want to isolate the radical. So we're going to subtract 8 from both sides. And then, that looks like times 8. But 50 take away 8 is going to be 42. And then we want to get the square root of L by itself. So we're going to divide both sides by a number that's being multiplied by the square root of L, which is 12.6. And that's going to give you 42 divided by 12.6 is 3.333 repeating. So I'll just keep a few decimal places there. And then you want to square both sides. So L would be, and I just still have that in my calculator, so I just hit squared, and that gives me 11.111, so on. So if I round that off, L is approximately 11.1, and that would be in meters, 11.1 meter skid mark. The next question says the period in seconds is the time it takes a pendulum to make one complete swing back and forth. This is modeled by t equals 2 pi square root of L divided by 32, where L is the length of the pendulum in feet, and a pendulum is like, kind of like if you've ever seen an old grandfather clock, the thing that hangs down swinging back and forth. You know, that's kind of like a pendulum thing, it swings back and forth like that. So determine the period of the pendulum if its length is 2 feet. So we have this equation here. T, we said, was the period in seconds, or the time it takes for it to make one complete swing back and forth. And it's equal to 2 pi, the square root of L, where L was the length of the pendulum in feet, over 32. So they're asking you to determine the period, so you want to find T this time when L is 2. So this time we don't have a variable under the radical sign, we just have a value under the radical sign, so we can go straight to our calculator now and work out what T is. So if you are going to put this in your calculator and you're going to do the square root part, make sure you put brackets around 2 over 31 if you're going to leave it like that. So if I put in the square root of bracket 2 divided by 31, that gives me 0.254000, so on. So then I can just multiply that by 2 times pi. And most calculators have a pi button. If yours doesn't have a pi button, I guess you can approximate pi with 3.14. And this is giving me 1.5959, so on. So that would be approximately 1.6 seconds, because t is time in seconds. Alright, so here's some practice questions for you to try. And the first one here says the radius of a cylinder can be found using the equation r is equal to the square root of v over pi h, where r is the radius, v is the volume, and h is the height. And we're going to assume that volume is, for this formula, is in meters cubed, height is in meters, and radius is in meters. So it says a cylindrical tank can hold 105.62 meters cubed of water. So that would be a volume, because it's a meters cubed. And the height of the tank is 2 meters, so what would the radius of its base be? So we're going to use this formula that the radius is volume over pi times h. And we're looking for r when we're given that the volume is 105.62 over pi times the height we're told is 2. So if you want to put this in your calculator kind of all in one step rather than doing parts at a time, you can just basically hit, if your calculator operates forward, hit the square root button, then put in 105.62 divided by bracket pi times 2, close your bracket, and it should give you the answer. Or if your calculator works with square root backwards, you'd have to put in the 105.62 divided by bracket 2 times pi bracket, and then hit the square root button. In any case, you should get the same answer. 105.62 divided by I'm getting approximately 4.1, and that would be meters, we assume, because all the rest of them are meters. Question number 2 says the surface area of a sphere with a radius r can be found using the equation s equals 4 pi r squared. How could you determine the radius of the sphere if you know the surface area? So, if we know the surface area and we're trying to find the radius, we just start with this equation, s equals 4 pi r squared. And basically we want to isolate the r squared, so we would divide both sides by 4 pi, so that we have just r squared on the left side or the right side of the equation. So r squared would equal s over 4 pi. And I'm just going to turn that entire equation around now. So we'd have r squared equals s over 4 pi. Just turn the whole thing around. And then if I want to get r by itself, I would have to square root the r squared, and that would give me r equals the square root of s over 4 pi. Okay, so the next example, or part of that question, asks you the surface area, or tells you that the surface area of a ball is 426.2 centimeters squared. What is the radius? So we're going to use our new formula that we just came up with, that r equals the square root of s over 4 pi, and r should be equal to the square root of, in this case they told us that s was 426.2 over 4 times pi. And again, if you're going to put in your calculator, put in 426.2 divided by bracket 4 times pi bracket. Because if you don't put brackets around the 4 pi, it's going to divide 426.2 by only 4 and then multiply that answer by pi. So you need brackets around because you want 4 times pi to be the thing that 426.2 is divided by. So 426.2 divided by bracket 4 pi, and then you want to take the square root of that. I meant to put that in first, but it doesn't matter, I can still find the square root of it after. Alright, so that when I put that in the calculator, it's 5.82 is what I'm getting. 5.8237, so on. So approximately 5.8, and that would be centimeters. Alright, so there's some questions there listed from pages 222 to 224 of the text that you can try to practice the ideas that we learned in this section.